solve the equation, cross out extraneous solutions. We have here a radical equation. It has a cube root in it. And recall that sometimes when we have radical equations and we undo the radical by taking both sides of the equation to a power, we introduce extraneous solutions. That's really a result of things that happen when we have even powers, even square roots or fourth roots or sixth roots. When we have these third roots, that's not going to be an issue for us. So it turns out that whatever answers we come up with are not going to be extraneous, but it's still a good idea to check whether or not the solution we come up with works. Keeps us in good habits, and besides that, there's lots of places where we could mess up, so it's a good idea. So I want to go ahead and get rid of the cube root. To get rid of a square root, we squared both sides of an equation. To get rid of a cube root, I'll cube both sides of the equation. Just like with square roots, though, I don't want to just cube directly, because if I were to cube this expression directly, I have a binomial cubed. And you know that a binomial squared is messy enough, all right, with those cross product terms at 2 times a times b, if we have a plus b quantity squared. A cubed thing would be awful. So I don't want to cube it right away. Instead, let's go ahead and add 2 to both sides. And that way I'll get this cube root of x cubed plus 56 all by itself on one side of the equal sign. On the other side, I have this x plus 2, which I'm going to have to cube when I cube my left-hand side, and it is a binomial, but at least it doesn't have any roots in it. So when I do this cubing, this side isn't going to be the nicest thing, but it's not going to be as bad as having a ton of cube roots show up. So let's do the cubing. I'll cube my cube root. The cube root and the cube cancel, and I'm left with an x cubed plus 56 on the left. On the right, some people memorize this binomial cubed formula. I'm assuming that we don't know that, so let's just go ahead and figure it back out. I'm going to do this in 2 steps. First, I'm going to view x plus 2 cubed as x plus 2 times x plus 2 squared. And now I'm going to multiply out this x plus 2 squared using my memorized binomial squared formula, which tells me this is x squared plus 2 times x. 2 times 2 is 4. So this is x squared plus 4x plus 2 squared, 4. So we get that. Now we have a binomial times a trinomial, so we can multiply those together. On the left, we still have this x cubed plus 56. On the right now, we multiply this together, and I have an x cubed, and I have x times 4x. I have a 4x squared, and I have x times 4, 4x. And I have 2 times x squared, 2x squared. And I have 2 times 4x, 8x. And I have 2 times 4, 8. So we get this big long mess. All right. So now we have a polynomial, x cubed plus 56 equals x cubed plus a bunch of other stuff. Let's go ahead and solve this polynomial, which we want to do by taking everything and throwing it on one side of the equal sign so that it's equal to 0, and then we factor and we solve. So let's do this. Let's subtract x cubed from both sides. The x cubes just go away. That's nice. And then we'll also subtract 56 from both sides. When I do that, I'll have a 0 on the left-hand side, and on the right side, my x cubed went away. I'm still going to have a 4x squared. I also have a 2x squared, so that gives me 6x squared. I'm going to have a 4x. I also have this 8x, so that's a 12x. And then I have this 8, and I also subtracted 56. So I have 8 minus 56, so that's a negative 48. So let's factor this. We look at it and we say, big numbers, hard to factor. But 12 is 6 times 2. 48, is that a multiple of 6? Yes, it is. So we can go ahead and factor out a common factor of 6 from each of these 3 terms. Take the 6 out of 6x squared, I'm left with a x squared. Take the 6 out of the 12, I'm left with a 2x. Take the 6 out of the 48, I'm left with an 8. So we have this much easier to factor polynomial. So we have 6 times 2 factors whose product is negative 8 and whose sum is positive 2. So this will be x plus 4 and x minus 2. So it looks like our solutions are either when x plus 4 is 0, so when x equals minus 4, or when x equals 2 from this x minus 2 equaling 0. So here are our 2 answers. You can go ahead and plug them in and check, but like I told you, when we're cubing things, we don't introduce extraneous solutions. So these are our answers.